Alright, now to the main difference between primitive and non-primitive types. The primitive versus non-primitive type. Okay. So for the primitive type, I'm just going to take a sample of both of them, of course, and this sample will be applicable to all of the types. So let's take, for instance, integer x equals 6. I declared an integer named x and I gave it the number 6 as the value, and then I declared another integer called y and I gave it like x as its value. So now x and y, they both have 6 as their values. Now in the memory called stack, okay, it's called stack. Excuse my drawing skills, they're not the best. I'm just trying. The value of x equals 6 and the value of y equals 6. Let's assume then you went ahead and changed the value of y to something like 7, or even wrote a mathematical operation. Okay, now, so now this value only will be changed. So this will be crossed, no longer 6, and it will be changed to 7. So now if you try to print out the value of x, it will remain 6. But if you try to print out the value of y, it will give you 7. Nothing will change for the value of x. That is why we call them value types and not reference types. However, we cannot say the same about the non-primitive types. Let me give you an example. Let's assume we have a class called person, and this person has an instance called person1, p1, new person. Okay, and then p1 dot name equal John. Okay, and I have another person p2 new person, and then p2 dot name, or just really p2, because if they have even more than one value, I would like to make them the same. So now p2 equal p1. Now let's look at the memory. We still have a stack, okay, but this time the stack will not hold the values, the actual values, and instead we have another memory called the heap, which will hold the value of the name. So name will equal John for both of them, okay, because they're all the same. And the stack of the first one, the p1, will only have a pointer or a reference number, or just the index of the heap that will point out to the heap. Let's assume it's in a hexadecimal, FE1, for example, and this will point to the heap. Okay, and now when I created the second instance, I created a new reference, EF2. However, this reference will refer or will point to the same exact spot. So now if you changed the name of P2, like P2.name equal Michael, okay, and try to print out the name, and so before that this name will be changed to Michael, or Michael, spelling is different, okay, doesn't matter really. And now if you try to print out p1.name, it will give you Michael. John will no longer be in the heap. John will be wiped out of the heap, so it will no longer exist. And instead we'll have Michael. And if you change something for p1 as well, it will change in the heap, and the both references or the both instances will refer to the same spot. That means it will change for both of them. That is why we call them reference types and not the value types. Now let's take a look at the code, and let's assume I have integer number 1, for example, and give it like 80. Okay, and I have integer number 2, and this will be equivalent to number 1. Okay, and now console write line. Okay, number 1, I'm just gonna copy the whole thing really, and number 2. Okay, debug. Okay, they both equal 80s like expected. And now let's change the value of number 2. So number 2 now equals 100, for example. Okay, print out the values. So number 2 only changed, and now it's 100. It's no longer 80, and it doesn't really influence or affect number 1 value. It's still 80, right? As you can see. Okay, now let's take a look at the non-primitive types. Let's assume I have a class called person. This class has public name, string name. Okay, and I have 2 instances of the class, person p1 equal new person, and person p2 equal new person. And then I have p1 dot name equals Joan, for example, and then p2 equals p1. Okay, now it says top level statement must precede namespace and type declaration. Yeah, it says like this should be down here because this should be first. Well, technically I can explain why, because of the namespace. It's out of scope, but don't worry about it now. So now if we tried to print out person1 name, okay, and p1 dot name, just gonna copy the whole thing, and then person2 name, p2 dot name. Okay, let's print them out. They both are Joan. Okay, now let's change the value of just p2. Now let's make it Michael, for example. Okay, execute. Notice that both of these names have changed, not just one, both of them, because they both refer to the same spot in the memory, the heap. Remember? I think that's pretty much it. We covered the primitive and non-primitive types. Non-primitive types briefly, but we will explain them in details in the upcoming lectures. And post any comments or concerns or questions that you have in mind in the comments, and I'll make sure to read them all and to answer them as I can. Thank you so much.